Welcome to our tutorial on getting started with Apache Spark. In this tutorial, we'll walk you through the process of downloading and installing Apache Spark on your system. Before proceeding with the installation process, ensure that you have installed the most recent updates of Java and Python. You can check which version of Java you have by typing Java version in the PowerShell console, and you can do the same for Python by typing Python version. After installing Python and Java, you should configure system variables. To do this, press Windows +4 on your keyboard, type sizedm.cpl in the window that appears on the screen, click Advanced, then Environment Variables. In the window that appears on the screen, you can set the path variable for Python and Java. For Python, it should look as shown on the screen, and for Java, it should look similar. Now that you have Java and Python up and running, we can proceed with the installation of Apache Spark. First, open your web browser and navigate to the official Apache Spark website. Once there, locate and click on the Download tab. You'll be presented with several options for downloading Apache Spark. Choose the latest version and select the appropriate package type for your system. After selecting your preferred options, proceed to the download page. Once the download is complete, navigate to the location where the file was saved. Right-click on the downloaded file and select Extract to unzip the contents. Choose a suitable location on your system to extract the files. This process may take a few moments depending on the speed of your system. Next, we need to set up the environment variables to enable Spark to run smoothly. Navigate to the directory where you extracted Apache Spark and locate the conf folder. Inside this folder, you'll find a file named sparkenv.h template. Copy this file and rename the copy to sparkenv.sh. Now, open this file in a text editor and add any necessary environment variables, such as Java Home, to point to your Java installation directory. You can ensure that you have correctly configured the Java Home variable by typing getChildItemEnv in the PowerShell console. If you see Java Home in the list of variables, it means that this variable has been properly configured. Before we can start using Spark, we need to configure some settings. Navigate to the conf directory within the Apache Spark installation folder and locate the sparkdefaults.conf.template file. Copy this file and rename the copy to sparkdefaults.conf. Now, open this file in a text editor and configure any necessary settings, such as the master URL and executor memory. You can check if Spark is functioning without making changes to the sparkdefaults.conf file. Default values will be used if no custom settings are provided. If you want to verify whether Spark is functioning correctly after installation, you can run one of the basic Spark commands in the terminal, such as Spark Shell for Scala or PySpark for Python. If Spark has been correctly configured and is working, you should see the Spark logo and an interactive Spark console that allows you to execute Spark commands. If both of these commands run smoothly and enable interactive work with Spark, it means that Spark is installed and functioning properly. Now that we have successfully installed and configured Apache Spark, let's delve deeper into what this powerful program is all about. Apache Spark is an open-source distributed computing system that provides an interface for programming entire clusters with implicit data, parallelism, and fault tolerance. It was developed to handle big data processing tasks efficiently and quickly. Let's take a look at some of the key features of Apache Spark. Speed. Spark is designed for speed. It performs in-memory computations to increase the processing speed of large-scale data processing tasks. Ease of use. Spark offers easy-to-use APIs for programming in languages like Scala, Java, Python, and R, making it accessible to a wide range of developers. Versatility. Spark supports a variety of workloads, including batch processing, streaming data, machine learning, and graph processing, making it a versatile tool for various use cases. Scalability. Spark scales efficiently from a single machine to thousands of machines, enabling it to handle large-scale data processing tasks with ease. Now, let's explore some common use cases where Apache Spark excels. Big data processing. Spark is widely used for processing and analyzing large volumes of data efficiently and quickly. Real-time analytics. Spark's streaming capabilities allow organizations to perform real-time analytics on streaming data, enabling them to make timely decisions based on up-to-date information. Machine learning. Spark provides a powerful machine learning library called MLlib, which allows developers to build and train machine learning models at scale. Graph processing. Spark's GraphX library enables the processing and analysis of graph data, making it suitable for applications such as social network analysis and recommendation systems. In conclusion, Apache Spark is a versatile and powerful tool for big data processing and analytics. Its speed, ease of use, scalability, and support for various workloads make it a preferred choice for organizations dealing with large-scale data processing tasks. With Apache Spark, organizations can unlock valuable insights from their data, drive innovation, and make data-driven decisions to stay competitive in today's data-driven world. I hope you've learned something new today and that your Apache Spark is now working properly.